Last time, I mentioned Euler's equation, where e to the power of I times pi is equal to -1. This is a special case of Euler's formula. E to the I pi is equal to cosine of x plus I times sine of x, where x is equal to pi. Of course, cosine of pi is equal to -1, and sine of pi is equal to 0. Therefore, e to the I pi is simply -1 plus 0 times I. This can be simplified to e to the I pi is equal to -1, since anything multiplied by 0 is 0. This can also be written as e to the I pi plus 1 is equal to 0. But where does Euler's formula come from? The Maclaurin series of e to the power of x is the sum from n equals 0 to infinity of x to the power of n divided by n factorial. Therefore, we can write e to the power of ix the same way, where instead of x, we have I times x. If we were to write out the first few terms, we would get the following. Each term has I exponent a different number. But we saw from the previous video that I squared is simply -1, so we can write this as such in the next line. I cubed is simply I squared times I, so that would be -I. I to the power of 4 is I squared times I squared, which is -1 times -1, which gives +1. I to the power of 5 is I to the power of 4 times I, so that's just I. You may notice that there's a cyclical pattern here. 1, I, -1, -I, 1, I, and so on. This pattern would continue to infinity. As a result, we have real and imaginary numbers alike. So let's group the real numbers together and then group the imaginary numbers together. As a result, we can simplify the imaginary terms by taking out the I. Now we have two series. The real series, if we were to expand and continue it, would be the sum from n equals 0 to infinity of x exponent 2 times n divided by 2 multiplied n factorial. This is the Maclaurin series for cosine of x. Now if we look at the imaginary series, it's equal to the sum from n equals 0 to infinity of -1 to the power of n times x to the power of 2n plus 1 divided by 2n plus 1 factorial, which is the Maclaurin series for sine of x. Therefore, e to the power of ix is cosine of x plus I times sine of x. And that is where Euler's formula comes from, and therefore where Euler's equation comes from as well.